Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to discuss today is integer concatenation. The problem appeared in Starters 15 of October 21 and is a difficulty level of easy medium. The prerequisites to solve this problem include binary search. The problem statement goes as follows. We have been told that concatenation of two integers is obtained as follows. First, both the integers are treated as strings and then they are concatenated to each other. Meaning that if we concatenate two integers 6 and 7, the result is 67. Okay. Similarly, concatenation of 123 and 45 is 1, 2, 3, 4, 5. So you have to treat them as strings and then concatenate with each other. So given that, the question is that you are given an array A consisting of n integers and also we are given two integers L and R. Now we have to find the number of pairs I comma j such that the I comma j are indices lying in 1 to n, and also the concatenation of ai and ajth number is lying in the range L comma R. So the two given integers L comma R concatenation should lie in this range. Okay, concatenation of ai comma aj. So we have to find how many such pairs are possible. So to see a sample example, we have 5 elements with us and L is given as 28 and R is given as 102. So the array contains 5 elements. So starting with the index 0, so sorry, not index 0, let's take it as one indexing based. So this is index 1, 2, 3, 4 and 5. So starting with index 1, how many numbers do we have? We have a number 33 when it is concatenated with itself. Second one is 32, then we have 31, 39 and 3110. Similarly, starting with index 2, we have the numbers 23, 22, 21, 29 and 210. For third index, we have 13, 12, 11, 19, 110. For fourth index, we have 93, 92, 91, 99 and 910. For last index, we have 103, 102, 101, 109 and 1010. So out of all these numbers, uh, let me just show them clearly. Yeah. So out of all these numbers, how many lie in the given range? So the given range was 28 to 102. This is L and this is R. So how many of them lie? So just let's count them. Let's just circle them. 1, 2, 3, 4. We have 5. Okay. Then we have sorry, nothing over here. Over here, all of them are there. 4. Then over here we have 1, 2 and 3. So how many numbers are these in total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, the last one won't be there, right? 109 won't be there. So total 11 numbers we have. So the answer in this case is 11. Why? Because of all the numbers that we have formed, there are total 11 numbers or 11 pairs whose concatenation results in a number that lies in the range L comma R. So I hope the sample example is clear. Now let's see the solution approach. So to begin with the solution approach, first of all, you have to see the concatenation in terms of mathematical terms. So let's say we have to concatenate two integers x and y, then in mathematical terms, it is going to look like this. That is x into 10 to the power length of y plus y. What do I mean by that? Let's see through an example. So let's say x is one number, that is let's say 123, and y is another number 45. So on concatenating, we would get the number 1, 2, 3, 4, 5. But you can see that the same can be represented like 123 into 10 to the power 2, that is 100, plus the number y. So the number y was 45. So pretty basic stuff. Basically, whatever is the length of this number, second number y, is present over here in the power of 10. So in this manner we can represent the concatenation in terms of mathematical numbers. And in our question, we know that these numbers x and y are going to belong to the array given to us. So definitely we can't apply the brute force method because the number of pairs are too much. If we manually calculate for each pair, it is going to exceed the time limit. So we have to do something optimized. So what if we try to fix one of those numbers, and for one of those numbers try to count how many other possible numbers are present. Like if I fix x, how many possible y's are present, or vice versa. Can that help us? Let's see. So the expression given to us in the question was this, that is the concatenation of two numbers, the aith number and the ajth number should lie between L and R. For simplicity, right now just consider the two numbers as x and y, right? Because it will make it easy to write the equations. So let's write this in mathematical terms as we just saw. So L and R will remain as it is, but concatenation can be represented as x into 10 to the power length of y plus y, right? So we have two inequalities with us. One is the left inequality and one is the right inequality. If you are not getting what I mean, this is the left one. Okay, this is one inequality that we have, and this is the second one. So both of them can be solved if we fix the one number, that is either we fix x or we fix y. So fixing x is not going to help us too much because the term y is present in both the terms. I mean y is present over here as well as here as well. So if you fix y, that is going to be more helpful. Let's see what happens if we try to fix the number y. So the left inequality will be as follows. The left inequality will be, we'll have L minus y divided by 10 to the power ln of y. This will be less than equal to x. This is one inequality. Okay. And the other inequality is that we get it from the right hand side, that is x should be less than equal to r minus y divided by 10 to the power ln of y. So there we have two inequalities with us, and now the question has been simplified to other terms. That is, for a fixed y, we need to find the x such that it lies between capital L and capital R. Now you might be wondering, what is this capital L? So capital L is just another term for this whole big thing. This is called as capital L. I am calling it as capital L, and this is capital R. So our question is now changed. That is, earlier it was something like this. Now it has changed to something like this. But this is for one fixed y. These This inequality, you have to calculate the total number of x for all possible y. That is, first you have to fix y as a1, then you have to fix y as a2, then as a3, and so on. So keep on varying the y, and for each y calculate the total number of x possible, and that is basically the total number of pairs, right? Because you are fixing one of them and calculating the total count of possible other values. So that is basically going to be our answer. Now again, how to calculate this thing efficiently? That is, you have the array with you, the array is given, that is array A is given. So how do you count the number of entries in this array that lie in this range capital L to capital R? You don't have to iterate over the array. If you are again iterating in the array, then it does not make sense, because again it will have much more complexity, time complexity. It will be order of n square, which is not acceptable. So this thing can be easily solved using binary search. Why binary search? Because we need to find just the count, okay, and that too in a fixed range L and R, where L is definitely smaller than or equal to R, right? So what we can do is we can sort the array A, and once we have sorted the array A, we can apply lower bound and upper bound to get the extremes, okay, and then their difference will give us the total number of elements in between, right? So if you are not familiar with binary search or counting elements, I suggest you read about lower bound and upper bound, which are well-known STL functions in C++. They are very helpful in counting these kind of things like number of entries lying in the range L comma R in an array. Okay, these are well-known problems for binary search. So that's it. We have simplified the problems for us. Now let's see the implementation in C++. So the implementation goes as follows. First of all, we take the input for number of test cases. Then for each test case, we take the input n, l and r. Okay, that is the three variables. Now we create the array and take the input for the array elements. After that is done, we sort the array because we have to apply binary search on this array later on. So remember, binary search can only be applied on a sorted array. So don't make the mistake of applying functions like lower bound and upper bound on unsorted arrays. Okay, that is a common mistake people do. So make sure you sort it beforehand. Then I have my answer variable set to 0. Now I vary my y, that is each element in the array. Okay, so I'll be fixing the element y and I'll be counting the total different possible x. So I have kept the same nomenclature as we discussed over here, that is x and y, so that it's easy for you to understand. So there we have, I have fixed my y. Now how to calculate length of y? This is again another trick. Length of y is basically log of y to the base 10 plus 1. Why this works? Again, just take 4 or 5 examples and you will see how this works. Alternate way is converting y to a string and then calculating its length using the inbuilt method. But this also works. You can use this as well. Now once we have the length of y, I am calculating something called as d. Now what is d? D is basically the denominator, that is 10 to the power length of y. As we saw over here, the denominator is 10 to the power length of y. So that is basically my denominator that is calculated over here. Now I am using my own power function because there are some issues with the inbuilt power function in C++ or C language in the precision. So it's better to always write your own power function and use that. You can find many articles on internet about the same. So once after D calculated, I now calculate the values of capital L and capital R, which is basically these numbers, these these present in circle. Okay, so L minus Y divided by 10 to the power length of Y. So that is over here, capital L. Okay, I am just taking the seal of the value because it may happen that we are getting a fractional number as well. So we don't want that. Also for R, we don't need to take the seal. We can just take the floor. So R minus Y divided by D. And there it is. We have the values of capital L and capital R calculated. Now we just have to apply upper bound and lower bound. That is basically binary search. So these are upper bound and lower bound are implementations of binary search, but exactly what they are, you can read about them on the internet. They are very helpful in competitive programming. So once we have the upper bound and lower bound, I just subtract them to get the total count of x such that it lies in the range L comma R, and that is added to my answer. And this is done for each possible y. That is, I am fixing y each time to different elements present in ARR. And that completes with my solution. I finally get the variable answer with my final answer. So I just output it. So this completes the implementation. Now, to check the correctness of the solution, it is always better to submit it on the CodeChef problem page. So that's what I'm going to do right now. I'll just copy the code and I'll paste it on the CodeChef problem page, and the language will be C++17 because I'm using the latest C++, and that's it. Now we have to wait for the verdict of the solution. Great. So our solution works. So I hope you guys understood my solution. If you have any doubts, you can post them in the comments below. I'll try to answer as much as I can.